Pre-college, law of cosines. The law of cosines formula is found on your reference sheet here. And it says a squared equals b squared plus c squared minus 2bc cosine a. Now, it's not always going to be a, b, and c. Your triangle might not be lettered at all. But what's important is that there's only one angle involved here. And in this particular problem, they're calling it angle A. And notice that all three sides are involved, A, B, and C. But only one of them is on the left side of the equal sign. And that's the one that is opposite the angle you're using. So if I'm using angle A for law of cosines, and side A is the one that's on the left, and sides B and C are the other two sides here. And so say I instead was using angle C, then it would be c squared equals a squared plus b squared minus 2ab cosine of angle C. And if I was using b squared, b and angle B, then B would be here, and A and C would be here, and cos B would be here. So it depends on what you're using, but the side that is alone on the left is opposite the angle that you're using in the problem, and then the other two sides are in the middle. So let's take a look at a problem where we could use this formula. A equals 4, B equals 3, cosine C is negative a half. What is C? Now, for most of these questions, you're going to first be at, now today is a law of cosine day, so we're using law of cosine, but on the other questions, like what we're doing in the next video, it's going to be mixed with law of sine, and so the first question is going to be, should I use a law of sine or law of cosine? And the key for law of sine is we want to use law of sine first because it's a little bit less work. But for law of sine, you need a complete set of a side and an angle across from that. If you don't have that, then you know it's law of cosine. Like, take a look. We have side A. Do we have angle A measurement? No. We have side B. Do we have an angle B measurement? No. We have something for angle C. Do we have a side C measurement? No. So you can't do law of sines without a complete set. So that's how you know it's law of cosines. Plus, there are 1, 2, 3 sides involved. Even though one of them's missing, it's involved. And one angle. That's another law of cosine hint. That 3 sides and 1 angle. Where law of sines tends to be 2 sides, 2 angles. So anyways, I want to find the length of C. And so I'll write my formula in terms of C. So C squared equals A squared plus B squared minus 2AB cos angle C. And I basically fill in what I have. So A squared here, that's going to be 4 squared plus, just fix that 4. B squared is 3 squared minus 2 times 4 for A, 3 for B, and cos C is negative a half. Again, if they gave me angle C, like if they said angle C was 30, then I'd be doing cos 30. But they gave me the function, not the angle. We always got to watch out for that. And so you want to evaluate these one at a time. Let's see, 4 squared, that's 16, plus 3 squared, 9. And then this is all being multiplied. Negative 2 times 4 times 3 times negative a half. You can type it all into your calculator. I could tell right away it's going to end up as positive because I have 2 negatives. But let's see, the negative half and the 2, that's going to cancel each other out. Or really, it's going to be 4 times 3 is 12. But you can do it in your calculator. So C squared equals 16 plus 9 is 25, plus 12 would be 37. It's an ugly looking C. And so C equals, then you do the square root of both sides to get rad, 37, and that's our answer there. Let's try another one. Number 2. A is 4, B is 3, C is also 3. What is the value of cosine A? And so, again, law of cosines, because 3 sides, 1 angle. I don't have a complete set between side and opposite angle. And I'm going to write my formula in terms of A because that's the angle I'm using. So that would be A squared equals B squared plus C squared minus 2BC cos A. Fill in what I have. 4 squared for A squared, 3 squared for B squared, 3 squared for C squared, minus 2 times 3 times 3. And I do not have cosine A. That's actually what I'm solving for this time. And so this is a little bit different than the last problem because you were solving for the thing on the left. And so you just did all the work on the right, and that was it. But this time, we're solving for something on the right. And so we need to simplify all these things and then move them away from the cosine A. So let's see, 4 squared, that's 16 equals 9 plus 9. And I can evaluate at least the negative 2 times 3 times 3. That's negative 6 times 3 is going to be negative 18 cos A. And now this is being multiplied here, negative 18 cos A, but this 9 plus 9, these are separate. So the first thing I want to do is I want to subtract the 9 and the 9, which is the same as subtracting 18 over on this side. That's going to give me negative 2 equals negative 18 cos A. And to get cos A alone, divide negative 18 on both sides. And negative divided by a negative is positive. 2 divided by 18 is 1/9. So 1/9 equals cos A. The problem could go further and say, what's angle A? Which we would then do inverse cosine, second cosine, 1/9, and get angle A. But it just wanted cosine, so we're good there. Let's try another. In a triangle, the sides measure 3, 5, and 7. What is the measure in degrees of the largest angle? All right, so this one's a little different. First of all, there's no letters involved, right? There's no A, B, and C. But if I have sides of 3, 5, and 7, clearly not drawn to scale here. The largest angle, and this is a geometry relationship that you learned last year, that the largest angle is going to be opposite the longest side. So that would be here. I'm going to put that X there, opposite the longest side, 7. And so that's what I want here. I want this angle. Let's call it angle X. And so it's kind of like what we were doing in this previous problem where I was finding the angle or cosine of the angle, but I could have then just did inverse. It's the same thing here. I want to know what is this angle. And so I'm going to write my formula, but the side that's going to be on the left is going to be 7. Again, there's no A, B, or C, but I know that the side that's on the left is always opposite the angle I'm using. And since this is the angle I'm using, you know, it's opposite the longest side, that would make 7 the side on the left and 3 and 5 the other two. So 3 squared plus 5 squared minus 2 times 3 times 5 times cos X. And evaluate. 49 equals 9 plus 25 minus 2 times 3 times 5 is 35. Right? Oh, no, I think that's 30. That's 6 times 5. Negative 6 times 5 is negative 30 cos X. Subtract the 9. Subtract the 25, which is a total of subtracting 34. And 49 minus 34, what is that? 15? Right? Yeah, 15 equals negative 30 cos X. And divide out that negative 30. Remember, I can't add negative 30. I can't add 30 because this is being multiplied here. So divide negative 30. 15 divided by negative 30 is the same thing as negative 1/2 equals cos X. But unlike this problem where that's what I wanted was the cosine ratio, this time I actually want the angle ratio. And so I'm going to have to do in my calculator the second cosine of negative 1/2 to get an angle measurement. We always do inverse functions, the second functions, and we get 120 degrees as our final answer. And that's it for law of cosine. It's kind of a long, somewhat annoying formula, but it's really not too bad if you just plug it in and go from there. All right, that's it. See ya.